encryption, all that complicated stuff is possible in JavaScript. People have actually done the work of implementing the algorithms. Okay, so attackers go out and they post those signed payloads all over the site, all over the internet. Okay, so then our central point of failure is Google. Okay, so then we use Google to search for some token. So the token could be base 64, today's date plus some secret. Okay, we don't care that other people discover the secret. So the victim queries Google for that token using JSON because we can use remote scripting. So then all these different sites are going to come back in the search results. Okay, so these are the sites where we planted those signed payloads. So the good guys come and they try to poison us. Okay, they try to poison the results because that's what good guys do. But the problem is, when they try to send in a self-destruct message, the new victim is not going to execute the payload because it hasn't been signed by the attacker. The public key of the attacker is inside the JavaScript payload we gave to the first, to all the victims. Okay, so they can verify something that was, signed with the private key of the original worm author. Okay, so we have authentication. We have proof that the payload we're about to execute is actually coming from the worm author or the worm creator. Okay, so you might say, okay, well, we can get Google involved. Okay, well then I'll just use Yahoo, and I'll just hard code in 6 or 7 search engines that are going to allow me to do this thing. Okay, and when the worm looks up the results, you might say, okay, you could slow it down by making the first 100 results useless. Well, I'll just get random results between 1 and 1 million. So it would take a lot of work on the on Google's part to prevent this. And then even if they did put in that work, then I'm just going to use another search engine anyway. Okay? So maybe I'll use one from another country where it's going to be difficult for you to have influence over them. All right. So yeah, I got a link here for if you want to look at how they do all this encryption in JavaScript. Okay, intelligence. So Jeremiah is of the opinion that, and I think my boss was too, Jeff, that worms actually don't need to live that long. So Sammy's worm lived for 18 hours, right, and then it was taken down. I would like a worm to be able to stay up for days if I'm an attacker, right, as long as it possibly can. But the main purpose, the main financial purpose of an across-site scripting world would be to deliver adware or malware or something. So if you can get 2 million people to install adware, guess what? That's a lot of money. Okay, so you don't really need it to be lasting that long. You just want to get a bunch of people, and then you can get out. So, in a more elegant solution would be to remain dormant and just spread quietly, and just not be noisy about it. But they don't seem to think you need to do that. I'm actually becoming inclined to agree with them. So first 24 hours reach massive infections through this epic growth rate, and then you're gone and never seen from again. So we still have code red traffic bouncing around our networks. I don't know if you know that. So who knows if they're really never seen again. Okay, so defense. So if you get hit with cross-site scripting worm, then again, you're probably going to want to do search and destroy because you can't do the database snapshot restore because you're going to lose all your other application changes. So how do you search for all these different types of JavaScript that have been encoded and obfuscated in all these ways that Billy Hoffman talked about? Well, you can't. It's like impossible to signature that JavaScript. But the XSS vector itself is probably not going to be that different. Okay? So if my XSS vector for infecting your profile was style equals expression something, that's probably not going to change from profile to profile. We're going to need that to be the same. Even if we could find 5 cross-site scripting vulnerabilities on your site, it's only going to be 5 attack strings that we need to look for, despite how the payload of the attack string is encoded. Okay? Okay, so playing defense, if you're a social network, you need this kind of output filtering egress filter. Okay, so egress filter is something a WAF can do. I really actually don't even know what their capabilities for doing this are, but technically it can be done. So this is we discover quickly that we have a cross-site scripting worm going on because we have some pattern matching application level IDS where we can say, okay, well, we detect a substring being copied across a whole bunch of profiles. Okay, you have to have that if you're going to be a social networking site. So how about if we just set up a simple egress filter that commented out, a pivotal part of the attack string? Well, in this case, if we just comment this out, a 2-byte change, then the attack is never going to propagate because the attack code is going to be rendered inert. Okay, so we need this capability, these really agile response techniques. If MySpace had this in place, I mean, we probably never would have heard Sammy, right? He might have been spread for an hour and then never would have heard from him again. Okay, so that's very efficient. Anti-Sammy is an Owasp project that I lead with help from a lot of people. Jason Lee's helped a lot. Jerry